And closing with the keynote is Bryan Helmkamp, founder and CEO of Code Climate, and he's going to be talking about debugging your team's cycle time.
Thanks so much, Emma. Appreciate the introduction. So we've got a lot of content in 15 minutes, and that was a great introduction. We'll dive right in. So when we're talking about cycle time and we're trying to debug that, what does that mean? People use the term cycle time to refer to a few different things. For this talk, I'm going to be talking about code cycle time, which can be described as the time between when code is written and committed, typically on a developer laptop, and deployed into some type of production environment. So why cycle time matter? You can kind of think of cycle time as the heartbeat of your engineering organization, and nothing can really go faster than the amount of time it takes to get this code into production. And this has impacts both on the engineering side as well as the business side. On the business side, of course, you have faster innovation, which leads to competitive advantage in markets. We all have had this sort of realization that speed and stability are often positively correlated as opposed to working against one another. And finally, the team. We've been talking a bit about, okay, what is the impact on developers in terms of a high delivery environment? Developers inherently want to be productive and feel effective. And so having their code be able to make it to production quicker is going to have a big positive impact. And the research has shown that elite engineering performance correlates with faster business growth and higher profitability, all things that we're trying to create within our organizations typically. So let's say you figure out what your cycle time looks like today. Where do you stack up? These are benchmarks from the research, from the DevOps research assessment, the DORA metrics and DORA benchmarks. Elite performance, they describe that as a cycle time of less than 1 day, high performance of 1 day to 1 week, and then medium performance at 1 week to 1 month. Low would be 1 month, anything beyond there up to 6 months to get code out into production. So what are the best practices for using data in order to improve cycle time and drive increased efficiency and performance? I wanted to start here because I think these are very important. That data, specifically quantitative metrics, should always supplement qualitative data and not replace it. Data is not a replacement for a conversation, not even intuition. You combine all these things together for the best results. You have to interpret the metrics with appropriate context, look at what's going on around them. And finally, I strongly recommend whenever you're looking at metrics or KPIs to try to combine multiple KPIs together for a balanced view. So for example, if you're looking at a metric related to quantity, how many times are we deploying per week? Pair that with a metric already. So what percentage of those deploys are successful, or what percentage of them might be introducing incidents? And that's going to give you a balanced view. So how do you set cycle time goals? It sounds simple enough. We say, okay, cycle time is important, and we pick a number. In practice, there's a few more details to be aware of that can impact your success. First, you have to decide how you want to measure it. You can look at cycle time potentially on a commit level, for example. I recommend looking at cycle time on the pull request level because the pull request tends to be sort of the atomic unit of work that is moving through all of our software development processes these days, and they're already getting a lot of attention on each PR, and you can use that to be your unit for tracking. Rather than an average, I would recommend describing cycle time goals in terms of almost level objectives. So just like we might say something like we want 99.9% of our web requests to finish in under 300 milliseconds, with cycle time we can say something like we want 90% of our pull requests to have a cycle time of under 3 days. And that's going to give you a better sense of, are we getting better? Because it won't be looking at outliers. It'll kind of reflect the facts on the ground. And then finally, whenever setting a goal, I think it's sometimes overlooked to think about the frequency with which it makes sense to review the progress. A pitfall I see sometimes setting goals that are only going to change, where the metric is only going to change weekly or monthly, and then looking at it daily, and that's not going to actually be super helpful. So we're going to set that goal, and then we're going to look at the change over time, really the slope of the line as opposed to the starting point. With respect to cycle time, there's a lot of things that roll up underneath that, and I personally benefit from thinking in frameworks. So this that you're seeing on the screen right now represents a 4-part framework for understanding what rolls up into cycle time. We're going to look at time to open, time to first review, time to approve, and time to deploy. And we'll jump in and start with time to open. So time to open, we describe that as the time from the first commit or line of code written through to an open pull request. What's interesting is we've done a ton of analysis of data, and we discovered that time to open has the largest impact on overall cycle time. Now, you'd expect a relationship because time to open is a subset of the cycle time, but what we saw when we did the research is that time to open actually has benefits to every other phase of the pull request beyond when it's opened. So it's a great place to start. If you think about why that might be, opening pull requests quickly is going to lead to smaller pull requests, or sometimes we use the term small batch sizes, with all the downstream benefits. They're more likely to get reviewed quickly because developers will feel like they can review them without having to block off a whole lot of time. They're going to have easier approvals, fewer back and forths. Developers really appreciate that on the submission side, and less risky to deploy. So how can you decrease your time to open? One of the first recommendations I would make is look at reducing the amount of work in progress you have in your system. We talk a lot about WIP in the Kanban sense, often at the issue level. You can apply the same principle and look at, okay, how many active PRs does my team have going at any point in time? And by reducing that, you're going to benefit with a sort of positive influence on time to open. You want to maybe keep an eye on rework. When I say rework, I mean times when a developer is rewriting code that they themselves recently wrote. That's a natural part of the software engineering process. But if you look around and you see that developers are maybe you have someone who's writing a lot of code, but 50, 60% plus of that code is rewriting code that they wrote a few days ago, that can be an indicator of something like a late changing product requirement or unclear technical direction that can cause somebody to be kind of spinning on their own coding and their own laptop without having the visibility with the team. And then finally, you can look at pull request size. Smaller pull requests are going to get open faster, almost always. The second phase is time to first review. So this, we talk about the amount of time between when that pull request is opened or ready for review and when that initial review occurs. One of the first things that's interesting about time to first review is it tends to be more reflective of team collaboration patterns and workflows as opposed to individual behaviors. As inherently with a code review, you have at least two people involved. Slow reviews will actually drive up your work in progress and start working against you on the time to open side. And that makes sense, right? A developer, if they finish something or have it ready for review, they might make the review request, might go get a coffee. If there is not a review by the time they come back from that coffee, they're unlikely to just kind of sit there doing nothing. They're going to try to find some other way to be helpful or move something forward. Often that means keep track of work. And then you're going to have this kind of like stacking happening. And when you're looking at optimizing this variable, interestingly, you have to balance fast reviews, which can benefit the people who are submitting the pull request, with the interruption side or the context switching on the part of the review. You don't want to minimize this down to instantaneous code reviews, because that's probably going to result in having somebody feel very interrupted, whoever's doing the reviews. So how can you reduce time to first review effectively? 4 ideas here. One is to prevent what I call PR scope creep. So maybe the pull request got open quickly, but people keep adding on more to it, and now it's getting additional responsibilities. You want to have each pull request ideally representing one sort of reason for change and stay that way. You're going to need to build a culture that prioritizes review, and this is about sort of rewarding review and making sure that people know that coding is not the only activity that's important. Engineering is a team sport, and make sure those contributions feel equally important to coding contributions. You're going to want to look at review involvement. And when I say review involvement, what I simply mean is how reviews are distributed across the team. You oftentimes see a pattern where 1 or 2 people on a team will do the overwhelming majority of the code reviews, and spreading those responsibilities out has a number of benefits. It can reduce your time to review, but also be a great way to share with people who might be newer to the team or a bit less experienced. And you can consider tooling in order to improve the visibility. So there are many tools that you can use that can do things like send simple Slack reminders when a review is requested or pending for too long, and those can be really helpful. The third phase that we're going to talk about is time to approve. So this is really looking at, okay, after that first review occurred, how long does it take to actually get that green check mark stamp of approval and have a pull request that's ready to go? And one of the big challenges that I see here is oftentimes if you speak to people, even in the same organization or same team, and you ask them, hey, why do we do code review? What are we trying to get out of it? they'll provide different answers. You might have people saying, okay, we're doing code review to find bugs, improve the way the code is structured and maintainability, or just to share knowledge. And all of those are reasonable answers, and they're not mutually exclusive. But if there's not a clear alignment within the team on what's trying to be achieved, that can cause a lot of friction in the code review process. In any case, you're going to have to balance speed versus thoroughness and understand questions like, hey, what level of detail on the feedback are we expecting in terms of what's sort of left? And then when it's received, what's the expectation in terms of the actions? For example, is it expected that I resolve or address every single comment that's left on the review? So how can you reduce time to approve? 3 ideas. One of them is optimizing review coverage. And I use the word optimize deliberately in the sense that you don't want to sort of maximize or minimize review coverage. Review coverage just being, for example, the percentage of changes in a PR that are actually receiving some sort of review feedback. Increasing review influence. So at Code Climate, we use the term review influence to refer to the percentage of code review comments which generate either a response comment or a change to the underlying code. And this is going to help you understand what is the perception of the signal to noise ratio on the part of people who are receiving the typically higher is better up until a point. Expect probably somebody to respond to every comment or react to every comment, and that's natural. And finally, limiting review cycles. So review cycles, the number of times things are bouncing back and forth, that's really where you have the largest increase in time because it involves waiting on either side. And an SLO can be a great thing to apply here. For example, we want 95% of our pull requests to be approved with 2 or fewer review cycles. And with that, we'll move on to the 4th and final phase of the cycle time, which is time to deploy. And when we think about time to deploy, I'm referring to, okay, after it has that green check mark, that stamp of approval, how long does it take to actually get out the door? And this one is a bit more challenging to optimize because there's many different variables that can go into what slows things down at this step. But it's very important to optimize because it represents this final barrier between the value that's represented in the pull requests and the customers, because customers can't get it until it's in production. And also a critical indicator of continuous delivery practices and continuous deployment. So I break down the issues here into 3 broad categories: technical, behavioral, and process issues that can get in the way, and we'll go through each one in turn. On the technical side, it typically resolves down to missing or broken tools that are preventing code from being deployed. You're going to want to make sure that your CI environment is fast and reliable as a foundational level. Also, that you don't have things like flaky tests or flaky scripts that are causing things to have to be rerun. You're going to want to consider adopting feature flags. If you don't have that tooling available to you, then that can cause a lot of hassle. And finally, you're going to need to look at continuing to improve your production monitoring, because if you're doing continuous deployment and you don't have good monitoring and things are breaking, that's going to create a sort of environment where people are less likely to want to deploy, and that behavioral problem. And that's what we're seeing here. So if developers, they don't want to break things, that's a positive intention. Unfortunately, it can lead to undesirable outcomes like infrequent deploys. People are scared to deploy. How do you resolve that? There's no magic bullet, but you can create alignment around the benefits of continuous delivery. And those benefits are for everybody in the organization. You can have less risk, higher impact, and those sort of blameless culture that we've been talking about throughout the team. And as the leader, you're going to need to provide ongoing support and space for people to make mistakes. If the first time somebody deploys, the feeling that their boss was frustrated, that it broke something, they're going to be unlikely to repeat that behavior, and you've created a problem down the road. Finally, process impediments. These typically resolve down to 2 broad categories. One is on the testing side, manual QA typically being the culprit here. That's not to say manual QA is bad. It's just that getting it out of the way of your deployment process can be very helpful by leveraging automated testing as well as feature flags. The other broad category would be security and compliance. And on that side, it's also going to be a matter of automating as well as shifting left. So can you find ways to handle security earlier in the process and remove it as a blocker to deployment? That can be things like automating audits, static analysis, dynamic testing. The security people are still there, but can they be out of the way of the actual deployment critical path? So wrapping up, we looked at how to debug your cycle time by looking at the 4 important phases of cycle time and indicators that you can use to get a sense of what's going on in each one and move things in the right direction. I'll leave you with these 3 keys to introducing metrics into your organization. First, I would recommend starting with intentions. Make sure your team and your org knows why you're thinking about using data, specifically quantitative data, to help improve things for everybody. Don't assume they know what's in your head with your intentions. Second, it can be very helpful to address engineers' problems first. If you were to kind of go around to your team and ask them, hey, what's driving you crazy? Figure out a way to get an understanding of that and then resolve those issues. You're going to have a benefit to your process as well as your team morale as well as trust. And finally, once you're off and running, you can empower all of your team members to own the success and build that shared culture of understanding, accountability, responsibility, and efficiency. Thank you very much. That's all I have for you today. If you're interested in these ideas, I actually wrote a book about these topics. It's called The Engineering Leader's Guide to Cycle Time. It's available through the link that's on the screen, free digital copy. I'll also throw that in the Slack chat if people are interested. And that's all I have for today. Thank you so much for your time and attention.